The accompanying table describes results from a group of 10 births from 10 different set of parents. Here's our table. The random variable X represents the number of girls among 10 children. Use the range rule of thumb to determine whether one girl in 10 births is a significantly low number of girls. First, we're going to go into Statcrunch. The first thing I want to do is look at my values. They're all between 0 and 1. That looks good. I want to go into my summary stats columns, and I want to sum up my probabilities and make sure that it equals 1. And it does. And now, Stat Calculator Custom. This allows me to work with my X values and my probabilities. And now I compute this. I can get the mean, which is 5.035. And I can get my standard deviation, which is 1.703. Now the range rule of thumb, this is one standard deviation away from mu. So this would be mu plus 1 standard deviation. And let's say this is mu plus 2 standard deviations. Use the range rule of thumb to identify a range of values that are not significant. We want to find the largest value before I go into my significantly high values. And my significantly high values are going to occur from here on. This number right here is equal to 5.035 plus 2 times 1.703. And I get 8.4. All right, perfect. Now we want the minimum value. This is mu minus 1 standard deviation. This is mu minus 2 standard deviation. Mu, which is 5.35, minus is rounding to 1 decimal place, 1.6. Check it. Perfect. Based on the results, is one girl in 10 births a significantly low number of girls? Yes, it is, because if I draw my picture, and we know that here is our mu minus 2 sigma, and that value is 1.6. Anything lower than 1.6 is significantly low. Yes, it is. One girl is a significantly low number of girls because one girl is above the range of values that are not significant. Nope. Because that would mean it's here in this middle part. This is 8.4, and this is mu plus 2 sigma, and anything out here is significantly high. It's telling me that between here and here is not significant. What I would do, look at yes on B. One girl is a significantly low number of girls because one girl is above the range of values that are not significant. That would mean they're in the yellow, but that's not helpful. C, yes, one girl is a significantly low number of girls because one girl is below the range of values that are not significant. That's my answer. Good. These are significantly low, significantly high, and here between those two, these are not significant. And number 2. The accompanying table describes the random variable X, the number of adults in groups of 5 who reported sleepwalking. Open this in Statcrunch, close this, and again, my X's are numeric, my probabilities are between 0 and 1, And just to make sure everything is fine, I will sum my probabilities and I get one, all good. Find the probability of getting exactly 4 sleepwalkers among 5 adults. I'm going to go to Stat, Calculators, Custom. We've done this before, but this is a little different. And I hit Compute. I get my probability distribution. I get my mean. I get my standard deviation. This is the probability of X. And what I want is X equals exactly 4. I hit Compute, and my answer is right there, 0.023. Perfect. Find the probability of getting 4 or more sleepwalkers among 5 adults. I want 4 and 5, so I want greater than or equal, and I actually have to retype 4 or else it won't recalculate. And hit Compute, and now I have 0.03. Check answer. Perfect. Problem 3, when playing roulette at a casino, a gambler is trying to decide whether to bet $15 on the number 36 or $15 on the outcome of one of these 5 numbers. Find the expected value for the $15 bet that the outcome is 000123. We're going to start with our table. When X, P of X, and X times P of X. If I lose, that means I lose $15. And what's the probability that I'm going to lose $15? I have 5 out of 38. It's not going to be one of those 5. It's going to be 33 out of 38. If it was any of the 5 numbers, then I would win. This is negative $13.03. If I win, that means I win $90. And that equals positive 11.84. I sum these. My expected value should be negative $1.19, rounded to the nearest cent. Since the expected value of the bet on the number 36, that's negative 79 cents, which is bigger, negative 79 cents, is greater than negative 1.19. It's better to bet on the single number. Check answer. There we go. There is a 0.9988 probability that the randomly selected 30-year-old male lives through the year. A life insurance company charges $162 for ensuring that the male will live through the year. If the male does not survive, the policy pays out $100,000 as a death benefit. From the perspective of the 30-year-old male, what are the monetary values corresponding to the 2 events of surviving the year and not surviving the year? The value corresponding to surviving the year, as the guy who took out the policy, I lost $162. However, if I don't survive, I don't make any money, but whoever I leave that to is going to have a profit of $100,000 minus the $162 that I initially put in. Perfect. This number right here, just so I can put on the screen, is $100,000 That's the payout, minus the $162 that was paid for the policy. If the 30-year-old male purchases the policy, what is his expected value? We need to make our table. He survives. If he survives, my X is negative 162. And the probability of that happening is, it's right here. Let me highlight it. That's the probability that he's going to live through the year. 0.9988. And then I need another column here. X, P of X. That is negative $161.81. Does not survive. Now, our X is, if I don't survive the year, then I have 99,838. My probability is 1 minus this. It's 0.0012. My expected value is the sum of that, and I get negative $42. Negative $42. All right. Can the insurance company expect to make a profit from many such policies? Well, sure, because the expected value to the 30-year-old male is negative $42. That means to the insurance company, for every policy they sell, they make an average of $42. Yes, because the insurance company expects to make an average profit of $42 on every 30-year-old male it insures for 1 year. And there we have it. Thank you for watching.